Good afternoon. I wanted to take a few minutes this afternoon to go through some of your Unit 1, Week 2 assignments. I only have 15 minutes of record time in this tool that I'm using, so I may go through this fairly quickly, but you'll be able to watch this as many times as you need to. So in Week 2, Day 1, I want to take a minute just to look at scientific notation and significant figures, and I have this scientific notation worksheet pulled up for you. Notice that it is 2 pages, and one thing that I would tell you is that you can also work on practicing your significant figures on this scientific notation worksheet as well. That will help you, especially when you get to the second page with parts 3 and 4. So you probably remember scientific notation from when you were younger. You probably learned this in a math class or a science class at some point. But I wanted to take a couple of minutes just to go through and refresh you on how to do this. So we'll do example 1 there, 900. So if I have 900, and this is in standard or decimal notation, and I need to write that in scientific notation, I understand that my decimal is here. Okay, so we understand if there's not a decimal, it's at the very end. So this decimal is here, and I'm going from standard to scientific notation, and I'm going to move my decimal 2 places. I want to put it right behind the first digit in my number. So I'm going to move my decimal place 2 spaces. So my decimal is now here. And then I'm going to write those zeros. I'm going to have times 10 to the something. Okay. Well, I moved my decimal 2 spaces. So I know that my exponent has to be 2 because that's how many places I moved. But we have to decide, am I moving this, which direction am I moving this, and does it need to be a negative exponent or a positive exponent? So when I go from, if I go from standard notation into scientific notation, which is what I'm doing here. Okay, so this is what I'm doing. If the decimal moves to the left, okay, which is what I did, the exponent is positive. So in this case, I moved my decimal to the left, so my exponent is going to be positive. So I'm just going to have 9.00 times 10 to the second. If I look at another example, let's look at number 7. So number 7, 0.000656. Okay, and again, I'm going from standard notation to scientific notation. So the first thing I have to do is move my decimal. I'm going to put that behind, in this case, I want it behind that first non-zero digit, so it's going to go here behind this first 6, so I'm going to have 6.56, alright, and then I'm going to see how many places I move the decimal. So I've got 1, 2, 3, 4, so I know that my exponent will be 4, but now I've moved the opposite direction. So if my decimal moves to the right, then my exponent is negative. Okay, so if we're moving from standard notation to scientific notation, if my decimal moves to the right, which is what happened here, then my exponent has to be negative. So my answer would be 6.56 times 10 to the negative 4. Okay, now let's look at a couple of examples of going the other way. So in part 2, we have scientific notation. We want to take those to decimal numbers. So let's look at number 11, 6.10 times 10 to the 2. So I have 6.10 times 10 to the 2. And in this example, I'm going from scientific notation to standard or decimal notation. Okay. Now, I'm going to move my decimal to the end in this example because I'm moving it 2 spaces. So it's going to go to the end here. Okay. So I'm going to have 610. And how did I know to move to the right? Okay. Well, because I had a positive exponent. So if I'm going from scientific notation to standard notation, if I have a positive exponent, the decimal moves right. Okay, so I had a positive exponent, so my decimal moved 2 places to the right. Let's look at an example of a negative exponent. Let's look at 7.72 times 10 to the negative 1. 7.72 times 10 to the negative 1. In this example, I'm going to move my decimal to the left. And my answer will be 0.772. So if I have a negative exponent, then my decimal moves left. Okay, so if I have a negative exponent, my decimal has to move left. Now, let's look at significant digits. So when we look at significant digits, all non-zero digits will be significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, no matter where they're located in the number, are going to be significant. What you have to watch out for are the zeros. And within your class, there is a cheat sheet that I call them in the course resources. Right here, periodic table and cheat sheets. If you go to the Intro Chem cheat sheets, you've got the very first one are your rules for significant figures. So again, all non-zero integers are significant. Okay. Then we have to really just look at the zeros. How do we know that the zeros are significant? If we have a number like this where we have just a single 0 on the left of the decimal, it's not significant. That's for cosmetic purposes. It doesn't have to be there. It doesn't add anything to the number. So it is not significant. If we have zeros between the decimal point and a non-zero number, those are also not significant. Think, well, how do I know that? Well, if I was to put this in scientific notation, those zeros would not exist anymore. So we know that they are not significant. I have 2 zeros here in between my 4 and my 4. Those are significant. So anytime a 0 is between non-zero numbers, it is always significant. And then zeros at the end of a number to the right of the decimal point. So our decimal is here and we're to the right of the decimal. Those are also always significant because they tell us how precise that number is. So all non-zero numbers are always significant. Zeros in between non-zero numbers, always significant. Zeros at the end of a number that's a decimal, always significant. Zeros between a decimal and a non-zero number, not significant when it's to the right here. And then a 0, one single 0 to the left of the decimal is also not significant. So if I was to just look at a couple of these, like for instance, let's look at 11 and 12 here. If we look at 11, we don't have a decimal point. So because we don't have a decimal point here, those zeros are not significant. Okay? Because if we put this number in scientific notation, we would not have those numbers. We would not have those zeros there. We would just have 2.5 times 10 to the 3. So these are not significant zeros. Only the 2 and the 5 are significant. However, in this example, I have 3 significant zeros. All 3 of these zeros become significant because now I have a decimal, which would make these 2 zeros significant. And then any 0 that comes at the end to the right of a decimal is also significant. Again, because that tells us how precise that number is. So this 0 would also be significant. If we look at number 17 as an example, this 0 here is not significant. These 2 zeros between the decimal and the 2 also not significant. But the 2 zeros at the end are. So we would have 4 significant figures in this example. Now when we look at adding and subtracting versus multiplication and division, the rules are a little bit different. So let me jot those down for you. So when we're looking at significant figures, okay, and we have addition and subtraction, we're going to go with the least number of decimal places. So if I have 11.11 plus 12.1 plus 32.62, I'm going to go with 1 decimal place because this one has 2 to the right of the decimal. This one just has 1. This one has 2. So my answer should have just 1 decimal place. Okay. So then my answer would be, what is that, 55.83, I think. And so we would round to 55.8 because I just want that 1 digit to the right of the decimal. However, if I'm looking at significant figures when I multiply and divide, it's a little bit different. I go with the least number of significant figures, regardless of decimals. Okay, so if I have 1.23 times 0.687 times 3, doesn't matter with the decimals. This one has 1 significant digit, so our answer would have 1 significant digit. Okay, and I can't do that one in my head, so let me grab my calculator here. And we'll say 1.23 times 0.687 times 3. My answer is 2.53503, but I only need 1 significant digit. I'm going to round up, so my answer will be 3. So it's a little bit different between addition and subtraction and multiplication and division, and hopefully these rules will help you. If you have any questions, just be sure and let me know.